So we want to practice writing out some acid and base reactions. So looking at our first one on here, number 1, it says H2SO4 plus H2O. And so we identify this as an acid, and then we want to figure out, well, what do acids do? Well, they give away a hydrogen. And so only one hydrogen has to leave, not both of them, because this does have 2 available, but we can just have 1 leave. And so that hydrogen, of course, combines with the water to form hydronium ion, which is H3O plus, and then we'll also form then HSO4, and now it's going to be a 1 minus because it's the H plus that leaves. And if this is neutral and it loses a positive charge, then it's going to be left with a negative charge. So now we want to draw a model of this. And so if we draw H2SO4, so here's my 2 hydrogens, and then I have S, and then 4 oxygens. So there's my H2SO4. And I'm going to combine this with water. And so we can see now that we're going to have our water turn into the hydronium ion. And then now we have just HSO4. So that's only 1 hydrogen on it. And now I have the rest of my acid, which is now a negative charge on it. So we can see how there was the hydrogen was there, and now it's gone off of here. So, and now there was no hydrogen here, and now it's on here. So, and then this has a positive charge, and this has a negative charge on it. Now looking at number 2, we have CaOH2. So that is going to break apart, and this is a base because of the OH. And so we'd have Ca plus OH, 2 OHs. So I'll use this one as my Ca. And then OH is treated as 1 unit. It says use blue to represent hydroxide. So this is my hydroxide overall, OH. And so all this is going to do is break apart. Oh, sorry, I'm supposed to have 2 OHs on here. There we go. And so now I'm going to have my calcium, which is now by itself. And then my 2 OHs. Remember, it's not diatomic, so we wouldn't put those together like that. There we go. So that's how that's going to break apart. And then we have, this is our base, and we want to identify our hydroxide ion. So here would be the hydroxide ion. And number 1, this would be our acid, and then this would be our hydronium ion. All right. Another example that I want to go through is number 4. So number 4, we have HNO3, which this is an acid, and then we have KOH. So this is a base. So when we have an acid and base like this, we know it's going to combine in a neutralization reaction. So in a neutralization reaction, we form water. So that comes from the H here and the OH here. These 2 are the ones that combine together to form the water. And then the leftovers from the acid and base always form the salt. So here's NO3, here's K. So I'm going to form KNO3. So if I were to draw this out, here's my hydrogen and my NO3. And then I'm adding this to KOH. Here's K. And we're treating hydroxide as 1 unit. So now the H and the OH are going to combine together. And that forms our water. And then KNO3 is going to combine together as well. As our salt. So then this would be, we said is our acid, this is the base, and this is the water and salt, because it's a neutralization reaction. So we want to look at some examples of acids and bases and our knowledge of how they will react in water. So the first question on here, identify each of these as acidic, basic, or neutral. So for an acid, we're looking for an H. For base, we're looking for an OH. And for neutral, we're looking for neither of those. So if we look at NaCl, salt, so it doesn't have a hydrogen, it doesn't have a hydroxide, so therefore this would be considered neutral. When we have H2CO3, this H in the beginning is an indicator that we have an acid. Then KOH, because we have the OH on here, the hydroxide, that's going to be characteristic of a base. And KNO3, we do not have an H or an OH, so once again, that would be neutral. So really, if you're just given a chemical formula like this, we're really looking for a hydrogen, and typically it's going to be written at the beginning, just like this, and that would tell us that it is an acid. If we're looking at a base, we're looking for the hydroxide ion, and that's going to be written at the end. Then if we want to write an equation as HBr dissolves in water, so we have to identify HBr as an acid or base, because then we would know what would happen to it. So the H at the beginning indicates that this is an acid. So I write my HBr, and it's going to be in water. So I know that all acids give away their hydrogen. So this is going to go away, and it's going to go to the water, and therefore it's going to form our hydronium ion, which is H3O+, and then the leftover is just the bromine ion, or bromide. So the hydrogen leaves because it's an acid, combines with the water to form hydronium ion, and then bromide. So naming each ion formed, so the first one is hydronium, because it's H3O+, and this one is bromide. Then what we want to do is we want to draw a picture of this so you can kind of see what happens. So I've got my H and my Br, and then I'm going to add that to water. So water does contain hydrogen and oxygen. And so basically what's going to happen is the hydrogen is going to leave. So we'll have 3 hydrogen now attached to the oxygen. And then the bromine is going to be left by itself, and this has a positive charge on it. And then the bromine all by itself is going to be negatively charged. So this would be my HBr plus water goes to H3O+ and bromide. Then number 4, write an equation illustrating how hydrogen ions become hydronium ions. So it doesn't matter what the rest of the acid is, it still behaves the same way, where hydrogen is being given off. So hydrogen plus whatever combines with water, giving us H3O+. So that's how hydrogen ions become hydronium ions. Here's our hydronium ion. Hydronium ions are always associated with acids. So if you have HCl, it would still form hydronium, and then of course Cl would be by itself. So it follows the same pattern over and over again. All acids do. It doesn't matter what this part is right here. Does not matter. We always this remains the same, this one remains the same, and this remains the same. Then looking at the next one, it says calcium hydroxide is a base. So we know it's a base. We have the hydroxide right on here. And we want to see how this base would dissolve. So we'd have calcium hydroxide is going to separate into calcium, which is a 2+, plus hydroxide. So we're forming hydroxide ions, which means that it turns into a base. Then number 6, it says nitric acid is a strong acid, and that is HNO3. And it's going to neutralize. So neutralize means we're going to form water and salt, and it's going to neutralize potassium hydroxide, which is a strong base. So we want to write the overall equation. So here's my acid, here's my base, and this is going to be neutralization reaction, it says. So we always form water and salt. So the salt is always the leftovers after you have the hydrogen over here and the hydroxide over here. These two are combining together. This is what forms the water. So you have H and then OH, and then the leftover is K and NO3. So that is the salt. And K is a 1+, NO3 is a 1-, so that's a perfect match. So written just like that. So every neutralization reaction involves an acid and base. We form water, and then the leftovers from the acid and the base combine together to form the salt. Looking at other questions related to hydronium and hydroxide ions. Hydronium we know is related to acids. Hydroxide ions are related to bases. So it says, how do the concentrations of hydronium ions and hydroxide ions compare in pure water? So pure water has a pH is 7. So we do not have any more hydronium ions. We do not have any extra hydroxide ions. So these concentrations would be equal, because if you have more hydronium, that means it's going to be an acid. If you have more hydroxide, that's going to be a base. Well, it's not an acid or a base, so they have to be equal. Then the next one says, how do the concentration of hydronium ions, so once again, that's the acid, and hydroxide ions for the base, compare in an acidic solution. So you have to have, if you want to have an acidic solution, you have to have more hydronium ions. So hydronium would be greater than hydroxide, because this is an acid. And then in C, if you have a base solution, then the hydronium is going to be less than hydroxide, because this is a basic solution. So the pH can tell us if it's an acid or a base, and also if it's strong or weak. So you can have a strong acid, you can have a strong base. Remember, those would have pHs that are farther away from 7. And then you can have a weak acid and a weak base, and those have pHs closer to 7. So then I'll let you finish 9 and 10 on your own.